Intégration by substitution. You guys love questions like this. And in this problem, they want you to come up with the substitution. If you are doing further maths, you do need to know the substitution. If you're doing normal maths, they most likely will tell you. But it's important that you guys understand why they are giving you particular substitutions. So using an appropriate substitution, integrate all of this. Now, if they did ask you to come up with one yourself, it's a very rare occasion, but I have seen it. You have to focus on the root, okay? Now, root 9 minus x squared, it's a clear trig substitution, okay? You're not going to make that equal u or anything like that. This format is always a trig substitution. Where does it come from? It comes from our favorite sine squared plus cos squared is 1, okay? And we're going to rearrange this. Now, in general, if there is no negatives on the outside, you want to make the substitution of sine. Because if you make a substitution of cos, it's going to bring out negatives and it looks a bit more awkward. So here, if you were to rearrange it, you'd get sine squared is 1 minus cos squared, which does fit that, but like I said, in general, we don't want to bring out negatives because that's what it's going to do, okay? But you can try it if you guys want to. Not a problem, mate. So here, I'm going to get cos squared is 1 minus sine squared. But can you see it has a 9 over there? Okay, we have 1. So what I'm going to do is I'm going to times through by 9. Okay? Well, that means in terms of my substitution, I can't just let x equal sine u. Because if I sub that in here, I'll get 9 minus sine squared. Something needs to be in the front so that when I do square it, it matches this number. And that would be 3. Okay? If I sub in the 3, I'll get 9 minus, and when I square this, I'll get 9 sine squared. 9 minus 9 sine squared is 9 cos squared. Okay? So, keeping that in mind, I'm just going to erase this bit because we have to do the other substitutions as well. This, we're not going to do anything with it just yet. So we're going to change dx into du by differentiating dx by du. Sine differentiates to cos, so we'll get 3 cos u. All right, I'm going to write that down here so you guys just remember. We get the integral of 1 over x squared. When you square that, you get 9 sine squared u. Then we get the root of 9 minus 9 sine squared u times 3 cos u du. Okay? And going back to the substitution, if that was cos, this would be negative. It just makes things a little bit more awkward. So we get the integral of 1 over, nothing cancels just yet, but look at what happens now. We're going to get multiplied. 9 minus 9 sine squared, 9 minus 9 sine squared is 9 cos squared. Yeah, so that's going to be in the root, which when you root that, you're going to get 3 cos u times 3 cos u du. Beautiful, mate. Okay, so it's up to us to be able to integrate something like this. 1 over 9 sine squared. Now, another thing you guys should be trying to do is always take out constants. So this is a 9th, take it outside of the integral. And here we are going to make the guess using our guess method. But there's nothing I know that differentiates to 1 over sine squared. So I don't actually call this integration. With my students, I say anti-differentiation. They just think I'm being posh in it. But the reason I do that is because I want them to think of integration as differentiation. So what differentiates to 1 over sine squared? Well, I don't know. We don't have a function. But if I rewrite it, so if I take out that 1/9, integral 1 over sine squared is cosec squared u du. Now, do we know of a function that differentiates to cosec squared? The answer is yes, it's cot. So I make a guess that it's cot u. But cot u differentiates to minus cosec squared. Okay, so minus cosec squared integrates to cot. So I'm going to have to times by minus 1. Okay, so I get minus 1/9 cot u plus c. Okay? Now, obviously that's not our answer because we wanted our function in terms of x. So we have cot u, our one in terms of x. We have a relationship for sine. So, going over here, the amount of working that's left is very minimal. So, the best way to do this is via triangles. So I'm going to say sine u is x over 3. Do a quick right angle triangle. So the angle u, sine is the opposite, so the opposite x over the hypotenuse 3. This missing side then will be, using Pythagoras, 9 minus x squared. Yeah, this squared minus this squared. Now we want cot. Cot, I mean, it depends how you want to think of it. So tan, what does tan do? Tan measures the relationship between the opposite and the adjacent. So cot will be the reciprocal of that. It will be the adjacent over the opposite. So cot of u is this over x. And that's going to give us our answer, isn't it? So our integral is going to be minus a ninth. And instead of saying minus a ninth, the 1/9, I'm going to put the 9 in with the x. So give us this. And that is our final answer. I mean, you could write it the other way around if you want. Maybe putting the constant first would make it look a bit more pretty. So c minus root 9 minus x squared over 9x. And that is our integral. So guys, if you enjoyed today's video and if you learned something, hit that like button and subscribe for more maths content like this. And if you're interested in my full A-level, GCSE or whatever courses, check the link in the description. I'll see you guys in the next video. Nice.